Look at this word, I. It is spelled E-Y-E from this side, and it's the same from this side as well. E-Y-E from this side as well. So I is a word which spells the same from both the sides. There are also several words like this in English. Level, refer, madam, dad, race car, and more. You can see that all these words spell the same from both the sides, and these words are called palindrome words. Do you have such words in your language? Share it in the comment box below so that we can all learn from each other. But what are we doing with words here? We need numbers, right? So look at this number, 232. It reads the same from both the sides, of course. 232, 232. There are several more numbers like this, 1, 2, 3, 2, 1, this way, and this way also it is 1, 2, 3, 2, 1. And 89998. It's the same from both the sides. Another example, 54145. You can have several examples like this. Even decimals behave the same. 20.02 this way, 20.02 this way. And 5555 is another special number which reads the same on both the ways. These numbers are called, of course, palindrome numbers. Unlike palindrome words in languages, we can do more things with palindrome numbers in mathematics. In Ganitika, we are going to deal with more palindrome numbers. Are you curious to know about it? Stay tuned in this video until the end. Let's take a non-palindrome number first. Of course, palindrome number, it reads the same from both the sides. There is nothing more to do in it. So first let's start with a non-palindrome number. Let's take an example of 53. It is not a palindrome number. 5 and 3, it doesn't read the same way from both the sides. But you can reverse the digits and add it to the original number. 5, 3 becomes 3, 5. Add it to that. This gives you 88, which is a palindrome number. Wow, that's interesting, isn't it? Let's take another example. 3-digit number, 253. Reverse this and add it to it, 352. Are you getting a palindrome number? Psst, no, 605. It is not a palindrome number, but we can continue the process. Reverse 605, it becomes 506. Add it, you get a palindrome number now. Just that you had to have an extra step to get to the palindrome number in this case. So the process is pick a number, any non-palindrome number, reverse the digits, add it to the original number, find the result and check whether the resulting number is a palindrome number or not. If it is, stop the process there. You got the palindrome number. If it is not, go back, reverse the resulting number, add and see if the result is again a palindrome number or not, and repeat the process. Let's go for an example. 435 is the number that I have picked. Reverse it, 534, add it together. The resulting number is 969. Is this a palindrome number or not? Yes, it is. 969 both the ways. So you stop the process here. Let's choose another number, 68, 2-digit number. Reverse the digit, 86. Add them together, 154. Is this a palindrome number? No. Let's go back, reverse the resulting digits, 154. Reversing this becomes 451. Add them together. The final answer is not a palindrome number. So go back again, use the number 605 now. Reverse the digits, 506. Add them together. The result is 1111. Is this a palindrome number? Yes. You stop here. So you finally got a palindrome number after several steps, right? How many iterations in each case we had? 435 added to 534, you got 969 in one iteration, just one step. Once you did the reversing of the digits, added them, you got the palindrome. So this has an one iteration step. Next, 253, 352 gave you 605. It was not a palindrome number. You continued for one more step. 506 added together gave you 1111, which was a palindrome number. How many steps? 2. Therefore, this had 2 iterations. Continue with the 2-digit number 68. It gave you 3 iterations. So 3-digit number gave you 2 iterations. 2-digit numbers sometimes gave you 1 iteration. In this case, it is giving you 3 iterations. Is there any connection between the number of digits and the number of iterations? No, there doesn't seem to be any connection between them, but you can check this out with more numbers and more iterations. So there is no correlation between the number of digits and the number of iterations to reach a palindrome number. Now you need to pick up a paper and pencil and try this for yourself. Use the number 9658 and do the process to reach a palindrome number? How many iterations were needed for this number to reach a palindrome number, and what is that final palindrome number? Are you ready for that? Pause the video here, complete this question and check for the quiz to continue with the video. Now let's do the palindrome process with decimals. Consider some decimal number, say for example 1.36. Reversing the decimals is 63.1. Be careful how the decimal is reversed. The decimal is placed in the same place as the original number between 1 and 3, and therefore the reversed digit will be between 3 and 1. And you got a palindrome number 64.46 on both the sides. In one iteration you got it. Let's go for another example. 6.8, as we used 68 before, we'll use it with decimal. 6.8 plus 8.6, 15.4. Reversing it, 4.51. Adding them, 19.91, and you got a palindrome number in 2 steps, 2 iterations. So nice number, 19.91 on both the sides. So decimals also give you palindrome number after certain iterations. Now for you to work on 5.39. How many iterations did you use to get a palindrome number, and what is that final palindrome number? The quiz is coming up, so pause the video, finalize this and give the answers to continue with this video. Does this work for all the numbers? Of course, there are numbers which have not reached the palindrome number after several iterations so far. Can you find out the smallest such number? You can do some research on the internet and find out what is that smallest number. Even after millions of iterations, it has not reached a palindrome number yet. And this is a very common problem in mathematics, which is more interesting to deal with. Coding this process. You can also use technology to code this process. There are several coding methods for this. Can you identify one? You can share this if you have one in the comment box below, so that the others can also get used to that. I hope you enjoyed this video. Share your experience with palindrome numbers in the comment box and we can all enjoy it together. Bye bye for now.